This is Mr. Warden. This is a video key for geometry exit ticket 25.1. So let's take a look at this one. So we've got this little pyramid sitting on top of plane N. So we ultimately need to prove that angle ABQ and BAQ are congruent. So it would help to prove that triangles QAP and QBP are congruent, because then we'll have AQ and BQ congruent, which would give us an isosceles triangle and do a nice job of proving that. So let's do that. So we know some things. We know BP is perpendicular to PQ. So let's label that. Okay, so we're going to try and prove that those triangles, that QAP and QBP are congruent. So we can say this. We know that those are perpendicular and therefore congruent. We also know that, well, that's because AP is also. So BP is perpendicular to PQ and AP is perpendicular to PQ. So that's my first two givens. Then A and B are equidistant from P. What that means is this. AP and BP are congruent. So we can say all of that stuff. So we know, okay, because of the givens, we know that angle QPA is right, and so is angle QPB, and therefore they are congruent. Okay. We also know that AP is congruent to BP because they are equidistant to P. Okay, then QP is congruent to QP because it is itself reflexive property. My goodness. Okay, so we know that. Okay, and with that information, we can say that those two triangles are congruent. We can say that triangle QAP and QBP are congruent. So triangle QPA is congruent to triangle QPB by side angle side postulate. Okay, now that will mean that we can go on to say, since we've proven these triangles are congruent, we asked, what does that say? What did that say about QA and QB, and why would that matter? Well, what it says is that QA and QB are congruent because of corresponding parts of congruent triangles being congruent. So QB, QA is congruent to QB by kappa conica. Okay, corresponding parts of congruent triangles are congruent. And why does that matter? That makes triangle QBA isosceles. Okay, so that's going to help us on the next one. The next one, if this triangle here is isosceles, if these two sides are the same, what that's going to tell us is that these two angles are also going to be the same. Because isosceles triangles don't just have two congruent sides, they also have congruent base angles. Okay, because QB is congruent to QA. We have an isosceles triangle. That's triangle QBA or QAB. Okay, and the base angles, angle ABQ and angle BAQ are congruent in an isosceles triangle. And there you have it. And that's what you need. I hope